Good morning and Salam Malaysia Madani and Salam Merdeka to all program participants. I hope you can all hear me very well. Hope today is a good day for everyone and everyone is healthy and excited to join us today. This program is held in conjunction with the National Science Week 2023, MSN 2023, brought specially for you by the Ministry of Science, Technology and Innovation. For this month of August, the theme is The Wonder of Engineering, where creativity changes tomorrow. Unleash the power of human innovation. Mimas Berhad, together with Maranti, will lead this engineering-based program for this month of August. For more information, ladies and gentlemen, various activities and has been arranged for everyone. So don't forget to visit our website, which is mangosciencenegara.gov.my for the latest information. I'm Lawrence. I'll be your host for today. Okay, Dr. Rosalie, how are you today?
Yeah, I'm good, Lawrence. Thank you very
You're
much.
good, eh?
Yeah.
Okay, we're also waiting for Mr. Salim to come to the camera. Mr. Salim, are you available now?
Yeah, I'm available in the camera.
Hey, Mr. Salim, nice to see you.
Yeah, okay.
Yeah, how's
Good.
things been so far?
Things are good. I'm going to be
Things are good.
getting off from my camera because of the bandwidth, right? So I'm going to be going off for after this, right? Is it okay?
Okay, Ken. But just give us a minute. Let me just introduce Mr. Salim. Okay, Mr. Salim is the general manager and co-founder of Square Cloud Malaysia Sdn Berhad. He's very passionate about um, GHG and energy saving using IoT and AI to optimize the building energy requirements since 2016. He's a frequent engineer in efficiency, graduated in industrial engineering from Technical University, Nova Scotia, Canada, with more than 35 years experience in FSCG and board manufacturing industry in Malaysia and Singapore in electrical, electronics, and semicon industry. Whoa, impressive resume indeed, Mr. Salim. Its main objective are increasing profitability and reducing costs. Therefore, the focus are on lean and efficiency from design to manufacturing processes to building OPEX after having to start up multiple plants and having to manage them to profitability. So with that simple introduction, ladies and gentlemen, I'd like to hand this session over to Mr. Salim, our first speaker for today. Over to you, Mr. Salim.
Okay, thank you very much, Lawrence, and good morning to everybody. I'm going to switch off my camera temporarily so that I can be presenting fluently, so that there's no disturbances. I will be sharing my PowerPoint. Hopefully, you will be able to see it. Are you able to see it now, right, Lawrence?
Yes. Go ahead.
Yeah,
Mr.
okay,
Salim.
so I'm just going to go through it. Basically, the topic of after being a TR technical recipient from MIMOS, I think basically the topic of discussion here will be the comprehensive energy monitoring, simplifying the OPEX reduction and pathway to net zero. I think this is a very urgent and required topic of discussion, whereby a lot of companies in Malaysia needs to know and how to implement this effectively and urgently, right? So why is it that we have to do it? But basically, we have to look at energy efficiency first before we go to renewable energy, whereby there's a lot of potential too in renewable energy. So I'm going to go into the next slide. My presentation outline will be the urgency. Why? Why is there an urgency in the SDG, the Sustainable Development Goals, especially the one that we cover, affordability and clean energy, the industry, innovation and infrastructure here, sustainable cities and communities, and climate action, right? So these are the four areas of what we most of the time when we talk about GHG and all the rest is all these four areas. The pre-positioning for net zero supply chain, right? Voluntary or is it a requirement? What is the cost? Okay, so that's what we're going to be at least covering. How can we make you implement them to achieve maximum returns and reduce operational costs or expenses or costs, right? So these are the key goals for a lot of why innovations is important, why partnering with MIMOS has helped us in a way and helping many companies in a way, right? So I'm going to move forward to the next slide. Before that is to reach net zero carbon emissions with fully integrated AI and IoT technology, right? Internet of Things. Later on, Dr. Rossley will cover some of the technology in terms of IoT and connected devices, right? Our climate crisis, we are not on track on 1.5 degrees Celsius. I think at the end of the day, you know that we don't have much carbon budget. If you look at the overall, we have 500 gigatons left, and we are emitting about 55 gigaton per year. Carbon budget will be exhausted within 10 years at least. So we probably will not have any chance of achieving the 1.5 degrees Celsius or 50% chance. So it is like throwing a dice, right? So the climate change, if you look at it, is reaching an urgency level, and we are on track. Not on track to the 1.5 degrees Celsius. This is what is being mentioned, and I think all the corporations, the worldwide, everybody is taking this very seriously, right? So with this, if you look at it, the cities occupy about 2% of the land, but contribute to about 70% of the global greenhouse gas, right? So the 60% of the global energy consumption and 70% of the global waste. So human activities in urban area, if you look at it, is the energy consumption from buildings and industrial. This is where we are focusing upon. And we do not want the sea level. For example, Singapore average daily temperature from 28 degrees to 35 to 37 degrees by 2100, right? That is a forecast, right? So the estimated sea level will rise, right, from 0.5 to 1 meter by 2100. So this is showing that there's going to be extreme weather if we do not take control of our destiny, right, of our future. So that's why there's a global net zero action happening, right? Net zero is no longer a vision, but a mission. To secure sustainable future that includes decarbonized economies as well as resilient, inclusive societies, the world needs to shift to renewable energy resources. At the same time, take into account their energy efficiencies in everywhere they are doing, right? In whatever they are doing. In Malaysia, we have targeted 2050. Well, China as a bigger entity, it targets 2060. But they are moving very fast in terms of energy, and also they are moving. They have the largest scale of solar energy and focusing on efficiency and renewable energy, right? So there's the government is introducing carbon pricing and carbon tax. You can see basically the goal is already now 1.26 degrees warmer than 1900s. So we have to make decision for the next generation. Okay. Last year we had the Bursa chairman talking about ignoring ESG will deprive a company, especially listed company, from equity and debt financing. Okay, so carbon pricing and its future in Malaysia is going to come, right? So if you look at it, and people have to focus in ST. There you have has already come out and say you have to appoint designated and registered electrical energy manager to manage if you have 3 million kilowatt and above, right? Well, our nations also take steps into three areas. Basically, if you look at it, the voluntary carbon market, and the emission of the trade system, and the carbon tax, right? So in terms of a voluntary carbon market is a buy-sell based on companies' commitment. In terms of compliance, in terms of with the capacity and a permit emission trading system. So the carbon tax also is one area that compliance with carbon tax. You need to know where your carbon is going, where you have to know the total supply chain, right? So I think there is a lot of hoo-ha. Even the government came out with a new energy policy and all the plan and the budget. So if you look at it, carbon market is going to change. It will be changing and it might get higher and higher. So depending on the market, even Singapore started off with their carbon market in at $5. It will go up to 225 US in 2024, right? If you look at the target here. Okay, so while we are all chasing after this, we also know that the TNB tariff rate hike is affecting operating expenses and carbon tax is coming. So if you look at the overall rate, in 2023, we have already seen a rise, right? So I think the electricity tariff increased in 2023 and tariff hikes average about 12.5% every 3 years. So the ICPT was 20 cents last half of a year and now it's 0.17 cents, 17 cents for commercial and industrial for July to December. So it is not something that is new for all of us. It is going to be a cost that is going to be increasing while we have to do more for the environment, right? And also for the earth. While we are doing all this, what is happening to the companies? Well, in the Standard Chartered review a study in London, in terms of what will Malaysian supply chain revolution for this going to be impacted? How is it going to be impacted? If you look at it, 78% of MNC will remove suppliers that impacts their carbon transition by 2025, 26, right? 35% of MNC current suppliers will be excluded in the process. That's huge, right? So if you look at it, if you do not go in with the transition of the carbon transition together with the MNCs because of the requirement that they are being put forth, so a lot of them will probably be excluded in their supply chain. Well, the emerging market suppliers are at risk more than the developed markets. You can see that. Okay. If you look at it, there's about US 1.6 trillion market opportunity in the 12 markets. 12 markets are listed below. And if you look at it, Malaysia has an impact of 65.3 billion per year. If you look at it, if 35% of the MNC current supplies will be excluded in the process, we will probably lose a certain percentage of this. So we need to be careful and we have to be ready, right? So in terms of Singapore, it is 146 billion US a year in Singapore, their impact. So Malaysia has 65.3 billion. So if you look at it, this is something that everybody is chasing. It's a domino effect, and 45% of MNCs will pay premium on an average of 7% for net zero suppliers. So what are we doing for the Malaysian supply chain going forward, right? So that is the most important thing. And how are we helping them? This is where MIMOS has come up with the technology and how Square Cloud has taken this technology and worked with MIMOS as a recipient and implementing in the for the supply chain that it has requirement for this GHG. Some of the problems we see is a lack of energy visibility. A lot of people don't see the leakages, where the energy is leaking, the rising costs, the sustainability policy and the pressures. Difficult to verify the energy. Is it accurate? What really happened? Sometimes when your energy increased by 10% or 5% in a month, what really happened, right? So, and also because of unplanned breakdowns or costs, unpredictable equipment failures, right? A lot of times these things happen and we see in all the plants. So with the lack of energy visibility, we really have to put in a real-time asset level energy monitoring. With the rising costs, okay, we have to put in the targeted, real target permanent energy reduction with fast ROIs, cloud-based carbon reporting system, that you can get your GHG, understanding your emission and how to reduce it, right? So we also need to have a professional monitoring and verification process, right? So this is something that is in international performance protocol. And we have to have asset tracking, which enables predictive maintenance with AI, reality AI, with AI that will be able to tell us that our equipment is going off or is taking more energy than is necessary. That means it's taking off more load, right, than necessary due to some problems in the equipment, right? So we need to be able to understand and have the breakdown of energy in the right manner. And this is a simple way of putting it for some small businesses, but for a bigger industry, there are many other ways. The roadmap to achieve net zero is monitoring and targeting as a start. Okay, I'm not saying that this is the end. When you have numbers, it helps you to measure, and with measurement you can do improvement, right? So data is important. So how can you get there? Basically, advancing to net zero. There's a lot of plans. People are now looking at new buildings when they are preparing for new buildings. It must operate at net zero carbon by 2030, right? So, and then 100% of the building must be operating at net zero carbon at 2050. So it is something that is we all have to put forth our plans, and not only for companies, but as a not only from the country, but as companies, individual companies, SMEs, that is supporting the MNCs and those put and export product, right? So are we going to be out from the supply chain, or we're still continuously going to be, or we're going to take this advantage so that we can be advantage to the supply chain, so that we will have more, okay, with the scenario that is happening? How are we going to take advantage and opportunity for this? Okay. So basically, when we work with companies, we really need to let them know where is the energy gap analysis. Then they do real-time monitoring and focusing on the energy savings, where there's no cost first, and then going to a technology-driven, right? And then later on, looking at a plan to hit net zero by 2035 or earlier, right? Okay, so the steps are basically quite clear, and we work with our customers and clients and telling them the urgency and the need, right? Okay, so and basically when you talk about real-time energy monitoring, it is basically you need to have a gap analysis and feasibility analysis. So you will probably need to look at your consumption and do a baseline or benchmarking with the real-time sub-monitoring. And then from there, you will then have the ECM regression model or AI machine language learning mode, and we will be able to look at it and see what is it that you can do differently to improve it. I'm going to go through a little bit of that later on, whereby after that, you're going to look at your reporting period of how you avoided the energy and the saving mode, right? All this is using the smart process, and all this monitoring will take at least 60 days of energy monitoring, establishing a baseline, right? The government has also come in to support the energy audit conditional grant. And what is it? SEDA and Surajaya Tenaga. They have come out and given industrial sector up to 100,000 per site per account for doing an audit, so that you can start off by getting yourself ready, right? For commercial sector, up to 60,000 per site, right? So this is what is happening. The government is putting forth millions of dollars in terms of supporting the industries, the buildings, so that they can go forth and start off and move forward towards their goal, right? What is the SEDA Industrial Energy Audit Scope? I'm just going to cover this. Basically, the one in gray is the energy scope. They're going to look at all your equipment. Number 1, 2, it's from chiller, refrigeration, pump, motors, cooling tower, AHU, compressed air, boiler, heat pump efficiency. It's going to cover all major equipment module. And they're going to look at your load distribution and building energy index, right? So looking at it and see how you can come up with the energy savings. But with this data, if you continuously look at it and improve and monitor with the right monitoring system, the opportunities are basically the design and operational efficiency, right? One is the equipment efficiency. Then how do you come up with the design and operational efficiency in the areas, looking at all your data, right? And how do you come up with a preemptive versus a reactive system that you are having today, right? So that you don't produce, you will not react most of the time, reactive versus preemptive, looking at system load management and control. The other part of it is that we always talk about lean when you are producing more than you are consuming, right? So if you look at your building, most of the time when you have chiller or air, you know, or heat pump, you are always producing more, waiting for it to be consumed. And in the process, you are losing the energy, right? You're losing energy, losses in energy during the process, during the reticulation, or during the overall pipeline, right? If you talk about air, it's leakages. When you talk about the chill water, you're talking about reticulation losses, right? So, and there's a lot of module load variation efficiency. How is it? Yeah, you are producing too much for one area to the other. Does not need so much. You know, how do you balance it, right? So it's a balancing of the load, making it sure that it's more efficient. At the end of the day, when you have these opportunities taking from the first step, it allows you to have allowing the definition of each product energy consumption and carbon footprint for the product, right? We call it a product carbon footprint, right? So you will be able to analyze and know whether, how are you going to define that, right? So this is the step towards it. The SEDA level energy audit covers a complete full audit, includes energy improvement breakdown, targeted percentage, ROI, from zero cost to minimum to medium cost. You will you will need to have a continuous monitoring of the changes above using IPMBP as shown. Energy management system that can validate the correlation of change and target the savings, right? So you use the IPMBP and the energy management system. That means you have a system to target and monitor. And this will give you a good basis for your ESG plan, right? When you come up with ESG reporting, and also for your greenhouse gas protocol, if you have the report category 1, 2, and 3. And this could also move you towards the ISO 50001, making sure that your organization follows the ISO standard. And also for ISO 14064, right? Which also have category 1, 2, and 3. So these are all the areas. When you start doing this, it helps you to move towards all these standards, right, and compliances. Okay. Why SCM and I, we do this as a service because we have we put in the system that implement a comprehensive energy management monitoring and control system to aggregate energy data from major equipment when they execute their energy saving measures, right? So this is what, and we utilize MIMOS technology to do this. Okay, this is a MIMOS technology has been implemented in many areas. I will so basically Dr. Rossley will go through most of them. He is able to take data and control and read and write and manage. And here we have a dashboard which he will go through with you, I presume. And we put in an AI system on premise and on the edge, whereby we will be able to take the data and trigger and be able to tell us what needs to be changed, right, automatically, and send the control to the locality, right. So I'm just going to go through some of this. So the first step is real-time energy monitoring, targeting, and reporting. If you look at it, number one, and it's the opportunity. Number two, focus on the bigger ones. That is either the plant or the compressed air. Then you can probably look at the heat pump and others. So basically, in terms of the first step is making it visible. Then if you have the saving capability that we see there is a need, there is a capability where the ROI is less than 2 years. Most of the time our ROI is less than 2 years. You can actually, we allow the customers to pay over 3 or 5 years using the pay as you save. in all this process, right? So we allow customers to do that so that they continuously don't have to have a huge investment towards saving the energy, right? But they have a capability to immediately have a carbon transition, right? So and making them what do you call that, able to meet the requirements of the MNCs whereby their carbon transition is needed immediately. When we talk about real-time AI and IoT energy monitoring, feedback, analytics, and control, so this is what we are going to be putting in place for customers so that they will be able to know and understand and make sure that they save 10% in 3 years. We will work with the client for continuous improvement. They will have they have the real-time monitoring and analytics to put in place with the hardware and software continuously for more than 3 years, right? So the dashboarding system will allow them to see the overall energy consumption, the current and alarms and everything. So the current ampere, and with this, we input all this into the a new AI, and the AI will then trigger and tell us whether the motor or the equipment is having a unpredictable and it's a predicted problem that is happening in the motor or in the equipment, right? So I think the government has given quite a lot of processes to help as long as the companies should be interested, I believe, submit the last 3 months TNB bill and appoint a ST licensed energy service company, right? So that's what it is, and work with them to kickstart and so that you can start your process so that you will not be excluded as one of the 35% that is excluded in the industry, right? So Square Cloud has a key partner with MIMOS and together with ICE and ICE has a key partner with TNB, right? So we work together and we have actually implemented energy efficiency project for more than 50 sites, project sites, right? So real time for whole plant room, giving cloud services. Well, we have done quite a lot in terms of buildings that we will be able to know from industry, from universities, from airport and hospitals and hotels, right? And also commercial buildings. So for offices that runs 10 hours for 5 days, we see a 15% reduction in their energy, especially in the chiller. For malls, especially in chiller, we see that we save about 18% of their energy, and for lighting, controls, and all this. So hospitals, we see about 22% average because they run 24 hours, 365 days. And for industry, it varies because on chiller and air, so it varies. It has an average of about 15%, right? Because of different types of industrial, right? Our current installed sites across Asia has been 12 sites in Thailand, 43 sites in Malaysia, 1 site in Indonesia, 1 site in Philippines. We have established in 2023 Thailand disti now after having 12 sites and Singapore, Philippines, and Vietnam. So we have worked with the DNZ, a Singapore organization, to work with us in Singapore, and they are also putting a foothold into Philippines and Thailand and Vietnam. Yeah, these are some of our customers, and we have done a energy saving project in Penang Airport, and our savings was about 13.9%. Hospitals about 18.6%. Hospital and 11.7%. Okay, so for hotels, for MIMOS wafer fab, we also see about 22. It ranges. This was about 2 years ago. This year it was about 16-17%. Last year was about 22%. TNB, Jalan Timur, we saw the building saving about 22%. So on the average, we say that we have been helping organizations save about 18%, depending on the type of building, right? Some of the mitigation case studies are making real changes with benefits towards the net zero emission with MIMOS, and we have been going into for large scale a large-scale food manufacturing project in brownfield, tracking the energy, chiller, the refrigeration, and the CDA operation optimizing is ongoing. TNBES has worked with us on ICE on the convention center project in Malacca, tracking energy and GHG emission. It has been completed. The saving is about 18 to 20%. For a large M&E assembly plant, we are tracking energy, GHG emission, basically more on the HVAC, CDA operation optimization. MNC electronic semiconductor project, brownfield, tracking energy, GHG emission. We are working on their chiller and CDA operation optimization, which is ongoing. Unicity, tracking on the energy and GHG, chiller operation optimization is ongoing. Frozen food manufacturing project, if you look at it, the tracking energy and GHG, chiller refrigeration operation optimization, which is also ongoing. So we have multiple ongoing projects while we have done multiple projects in place. But basically, if you look at it, our energy savings and comfort value proposition, or in any area in terms of it, is we are using AI and machine language, so preemptive in HVAC versus reactive HVAC, right? If you look at it, the existing HVAC system is more reactive, and what we do is more preemptive, right? So if you look at the preemptive, it is at a lower, it will be always be within their control limit, whereby for the reactive, it will always go, and then when you react, it will still goes over, and it will always going over the control limit, right? Unless you set your control limit at a tighter bandwidth, right? So that's what it is. Then with that, you will always have you have to use more energy. So it is more of a reactive that is losing energy. That means it's not lean, right? Preemptive is making you lean, right? We're talking about lean process and lean control. So in the reactive, you have a PID loop engaged. High accumulated delays when you have multiple PIDs take time to stabilize. But in the preemptive, you have AI that foresees the undesired event. Crossing of the cooling set point will happen and acts preemptively to control with learned data. So this is what it is. Over the time, the model will become more accurate. So I think basically, if you look at it, taking an example of cooling energy in plants and also in air, you have a problem statement, because every one of the plant, when you talk about air or chiller, I'm going to look at the cooling here, but it has the same effect in air. The problem statement is that unpredictable weather or environment in chiller, layout changes and renovation, and different equipment putting in, the requirements for the equipment has a different, more consumption of air. If here is a layout changes and renovation that requires more heat. Dynamic people load and production load because of their consumption and their process cooling requirement. The chiller performance difference, especially aging. Also, in any other equipment, you have your performance deteriorate, or if you do not maintain it well enough, or there is certain spikes in terms of requirement that something is happening in the motors or anything. So you have continuously changing heat load or air requirement. So basically, with this problem, that's why there is always a design factor of about 25% more capacity, right? And you look at the feedback loop is usually about 20 to 30 minutes feedback loop, and it takes time for, so you understand that we are sending more energy, but you are only using minimal, right? That means you're using only about 70% or 80% of the energy at any one time. So it's a very complicated process for a lot of us to understand in terms of how the overall system in a plant works, from extraction of energy, the pump sending out, and how it's a flow, the chiller system, what is the efficiency of the chiller, the pumps, how is it sending the chilled water, how is the efficiency of it sending it out through, and the AHU, right, the efficiency of the AHU, whether it has the real CFM, is it blowing the real CFM per kilowatt, is it efficient, right? So, and then with the dynamic load in the building, external of the building and also internal of the building. So there's so much factors that is impacting the overall, so that how much energy is being utilized. And a lot of this is based on making sure my chiller is efficient, and then making sure my AHU is efficient and the cooling tower is efficient. But at the end of the day, how is this being controlled? How do you manage the overall operation, right? Making sure that everything works simultaneously, and it comes to a sweet spot that you can make sure that you are lean, right? You are sending the right energy to the right place. All you need to do is real-time IoT feedback. And so you have a real-time actual load. Okay, so I'm not going to go into detail. I'm just giving you the complexity of buildings in terms of air or chiller or anything else. If you look at it, it has something more complex than just a straightforward reactive system. But you can have multiple reactive systems, but as you have more and more reactive system, this reactive system will then make you lose your efficiency, right? Okay. So we work on the patented intelligent chiller and energy efficient technology, which is validated by Unit 10, promoted by TNBES. It has an enthalpy in a function of temperature, humidity, airflow, heat gain factor. It works on psychometric analysis, building enthalpy characteristics, and heat gain. We have a control algorithm that we control the chiller together with the chiller manufacturer. So basically, so if you look at this, we'll be able to, if you look at the red line, this is what is without our system, and the one in blue line is the one with our system, right? So you can see the one in green and blue is our system. We help them save quite a huge amount of energy in terms of this. It ranges from 10 to 25%, right? I'm not going to go through. MIMOS use this technology and it's improving their energy. Okay. Basically, these are some of the calculation and methodology. I'm not going to go through. We have installed hardware components. Needs to be done, and it has to control. When you talk about our IoT, you need to have control sensors, and you need to monitor. These are MIMOS technology that we are using in terms of gateway and RHT, and you'll be able to take this data and do the AI and control, right? So basically, if you look at this, this is how MIMOS is helping us as a recipient, and we are trying to help more companies to implement this in the many companies. We need to work with a lot of SIs. So we want this to be something that is simplified and able to be implemented within a day, so that because it's easy to implement, right? When we talk about easiness to implement, look at a single line diagram with the new MIMOS which and operated with other BMS, right? So instead of having all this, it's just connected to the, and it's sent directly without any intervention or any wiring or anything. So all this is being linked to the RTD and also the chiller control, and it send the information and to and fro, right, to the control system. So RHT is wireless. So you can see that this is how the system is being implemented. This control is the which that has on the right side is taking the data for about 4 chiller or 5 chiller DPM. So this is how the which is installed and is linked to all the chiller DPM through the panels, right? So this is how simple it is. So I mean, we're not trying to oversell or MIMOS technology, but basically it has helped us to be able to move forward and make this fast. by having zero interruption in the factories, especially when you're talking about factories that are running 24 hours and they do not have extra capacity for you to work on, right? So zero interruption is something that is required. So previously, when we have to do a lot of wiring, the requirement is huge, right, for us to stop the equipment and having the people climbing up and doing all the wiring. So it's faster for us now, it's zero interruption. It saves, in terms of chip, because it saves time and cost, installation time and cost, right? So basically it's cheaper in a sense that, and it's good technology because it's able to read, analyze and control. And it can cover a huge, I think that in terms of technology, Dr. Rossley will cover that for all of you. And it helps us to grow, okay, and easy to scale up for our customers. From one to another, it can scale up, and it has multiple number of points. It can go up to about 1,000 points. So it's easy for us to scale up. So Mimos, working with us, has now started to work on this. And we've done, with this, we do the real-time monitoring and reducing the time that is required, right? So I'm not going to go through this, but summary and takeaway. AI and IoT solution by Malaysians, which is Mimos, Square Cloud, and AIs with the AI. We're building energy management, chiller, CDA, and major equipment AI with MySpark solution. We have been able to work on this and tested this product and implemented this product and seeing key results and good results, and even not only the results, but looking at the implementation methodology, right? And making sure that it's easy and people will be able to be trained how to do this. Continuous R&D to enhance and improve the current IoT devices and AI solution with WISP. Developing carbon emission and net zero measurement system in compliance to GHG and ISO standard for certification, because a lot of our SMEs require this. If not, they will not be able to transition, right? So we drive and support the MNCs and Malaysian SMEs in the export industry like E&E, etc., and making them competitive, right? So, you know, the urgency and the cost. So people say that when you're going towards ESG and GHG, the cost is going to increase. But here we are not trying to look at the cost increase, but looking at how you can utilize this to reduce your overall OPEX. So make it more efficient. And we are here to help the SMEs in their carbon transition process in line with their MNC's net zero plan. So we are helping a whole supply chain, right? The $65.3 billion yearly, right? We are talking about 30% or 35% of that is going to be about nearly 20 billion, right? They will be probably lost to somebody else, or if in this case, if we are able to help them, they will probably gain more, right, from other countries, right? So this is something that we have to put and help our SMEs and supporting industries, right? So the ESG, Net Zero, and MySpark product training, we actually partnering system integrator, partnering with multiple system integrators, more and more system integrators. Mimos is asking, and we are asking more system integrators to come in to be able to partner, and also partnering with energy and lean consultants, right? So they will probably be able to utilize this technology fast, and since it's fast, cheaper, and good technology and easy to grow, right? So this is something that is we are looking at, and we have started training Malaysians and Southeast Asia team in Singapore, Thailand, and Vietnam. So here it is. We can see some of the pictures of how the people that is being trained, right? Okay. So basically, the steps and stages of this is that first we have to monitor. Then the analytics comes into play. AI and machine language correlation, optimizing the energy versus consumption for your major equipment. Predictive failure is important because you do not want your failure to bring about your loss in OEE or loss in energy, using more energy. So basically, predictive consumption and emission is important towards the compliance of ISO, ISO, and GHG, which is now is an ongoing development in the version 2, right? So basically, I think get started on your clean energy and net zero journey for the SMEs and MNCs and SMEs. Thank you very much.
Okay, thank you. Thank you, Mr. Salim, for that very well explained detail about how to save energy. And if you have any questions, ladies and gentlemen, you can always type it in the chat, and the speaker will be able to see them. And if he misses it, I will also be able to bring it up to him. So you can always put in the chat box, right? Okay, there was a question on. Can you see the question, Mr. Salim? Or would you like me to read it for you?
Okay, let me try to get into a question now.
It's in the chat.
Let me look at the chat.
Yes, okay.
Trying to open up the chat. Okay. I didn't see any question yet. I only saw your box.
Okay, there's one. Can you please share more about SQ Cloud Tech solution versus other similar tech solution in the market?
Okay. I think basically there are a lot of other solutions in the market, especially using for monitoring. However, we utilize MIMOS technology, and I think Dr. Rossley will be able to share with you what are the reasons why I allow him to do that, because he and his group were the people that did the R&D and developed this technology. So the all the good things has to be said by him, right? So basically that's one. Number two is that Square Cloud does one thing extra, is that we do the analytics and we do the AI and other controls that helps in terms of energy efficiency. After you taking in the data, we look at how the methodology of doing that. So I think there's one page I talk about the energy efficiency, but the other one is talking about operational efficiency and lean operation, right, for your buildings, right? So that's what we focus upon. Okay.
Okay, and then there's one from Ms. Linda. She says if she can have some your slides. If you can share the slides, or at least some of the slides.
Yeah,
It's not,
I think you can share some of the slides. Yeah.
Later after the event, I guess we can email to our participants. Okay. Okay. Any other questions? If not, we'll move on to Dr. Rosli. Okay, there's no more questions. So thank you, Mr. Salim. Our second speaker is Dr. Rosli Mohammad Sabri from MIMOS Berhad. Dr. Rosli Mohammad Sabri is an engineer with over 20 years of research and development experience in the area of microelectronics and embedded system. Some of his research interests include wireless communication, the Internet of Things, IoT, sensor technology, artificial intelligence, and neuronic computing. He received his doctorate degree from the University of Edinburgh, UK, doing research in indoor positioning. So with that, ladies and gentlemen, I hand you over to Dr. Rosli. Over to you, sir.
Thank you very much, Lawrence. Anyway, good morning to all the attendants. I've seen we have about over 30 people in attendance today, which is quite good. And since also we have some from local and also from overseas. So so my presentation will be more towards explaining what is our technology that we have developed, and given the varied audience background, so I'm probably just gonna be talking on the surface. But if you have any detailed question, I think we can address those at the end of the presentation. Okay. Can I share my slides?
Yes, Dr. Rosli, go ahead.
Okay. So 1 second. Okay. Can you see my slide?
Yes, Dr. Rosli, we can see your slide.
All
Go
right.
ahead.
Okay. Sorry, I think I'll just also off my camera because to save bandwidth.
Okay, all right, go ahead.
So my presentation title today is how we use our IoT platform to help a company like Square Cloud to do energy saving for building. So in this particular case, we've used our technology for this smart chiller system. Okay, right. As presented by Mr. Selim just now, so HVAC or the ventilation, heating and cooling system is actually a critical plays a critical role in any building because it provides the it provides the. Hold on a second. Can you see my slide? Is it?
Yes, yes,
You
Doctor.
can you still see my slide? All right. I got lost. Okay.
Yes, nampak.
Okay. The HVAC system in a building is important because it provides the occupant comfort and to also monitor the indoor air quality, which directly affects the user productivity and health. And this HVAC equipment generally consume between 40 to 60% of the building total energy. So you have things like compressors, water pumps to circulate the chill water, and big fans to distribute the air towards the indoor environment. So all this machinery consume a lot of power. And then it's vital that if we can efficiently manage this HVAC, you can do an efficient HVAC management, and that's what is the key to reducing energy consumption and operational cost of the building. Okay, so next. All right. So one way that we can do this is by incorporating Internet of Things technology into the HVAC system management. The reason being, with IoT we can get a real-time operational data of the system, so that can help us to optimize the operation of the HVAC system. So, for example, if we could measure the power consumption of all the equipments, then we can know or we can evaluate how efficient are this equipment running. So we could do things like kilowatt hour per ton, or maybe some efficiency ratio calculation. So we could track over time how efficient are the equipment running, and if the efficiency drops, then it could trigger us to do maybe maintenance and to find out if there are problems with the machine. Same thing also, if we can measure the real-time temperature and humidity of the environment, then we can analyze what is the required load or the required demand for that particular time, and that can allow us to then put in a strategy to actually meet this demand. So we can actually we don't have to actually turn on the chiller at full blast all the time, because depending on the demand, we can either reduce it or increase it as required. So this ensures the system operate in an efficient point. Other things like we can also look at the supply and return chill water, because we could see at the pressure or the flow. Then this tells us that if there are any issues, for example, leaks in the system, or we can know also whether the heat transfer is being done efficiently or not. So all this data can be provided in real time by IoT sensors. And given the amount of data that we can get from this IoT system, the next step is actually we can even use this data with the help of artificial intelligence and machine learning algorithm. We can even predict whether some machine or some equipment is going to fail, or we can also detect anomalies in the system. So what this gonna help us is that it can actually lower our maintenance cost. So we don't have to actually do periodic maintenance every, let's for example, 3 months. So we can actually do what we call a predictive maintenance, that we only do maintenance when the failure is about to happen. Not yet happened, but maybe they give us time to intervene and do the necessary maintenance. So it also helps us to save on emergency repair. So because you don't want to wait until the equipment fail, then only you do the repair, because this will cost you a lot of money and a lot of downtime as well. So having these two, IoT and AI together, it helps us to minimize our downtime and also maximize our productivity. Right? Okay. So IoT is great. I mean, if we can do it, you can integrate IoT in the HVAC system. It's good, but it's not without any challenges. This is because normally, if you want to retrofit sensor or something autonomous or some system into an existing building infrastructure, this can be complicated. Mr. Selim just now said that took them, I think, months to wire all the sensors in before they came to us. All the sensors are wire based, so they have to lay down the cable, ask the production floor to shut down, and so all this costs money and time. So what is the preferred option is actually to go wireless. So with wireless sensor, you can just mount it at the location that is required, and you don't have to worry about laying cable and asking people to shut down their machine or their production floor. But if you go to the wireless, going to Wi-Fi or Bluetooth is not suitable for this application, because indoors, especially in big factories and also a commercial building, the coverage of Wi-Fi or Bluetooth is not there. So you have to put a lot more sensors just to get the data out to the network. Okay, and in the case of Wi-Fi, even some building owners also does not allow you to ride on their Wi-Fi network because of the capacity issue. Because you're going to have a lot of these IoT sensors installed. So if you use network wireless technologies like Wi-Fi, then you will be interfering with the existing capacity there. And also they are worried also about security problems. So that's why I think in our solution here, we don't use Wi-Fi due to this reasons. And what we have developed is actually a technology. We called it MySpark, which stands for MIMOS Smart Platform for Wireless Mesh Network. So essentially, our IoT platform is actually a wireless computing and communication platform to connect sensors and transducers to the internet. So hence the term Internet of Things. And this platform is meant for actually low bandwidth, low data rate, and low power applications. So things like getting sensor data to the internet, getting real-time sensor data, or maybe to control some transducers like pumps or valve. So all this requires very small but frequent amount of data. So this is what our platform is designed for, and it comprises of four components, namely the sensor nodes, the wireless sensor nodes, the gateway. We also have the back-end server that do all the database and also for the storage, and we have a web dashboard that display all the information. So the first two is actually the hardware that MIMOS has developed, the sensor node and also the gateway. And for the backend server and dashboard, we use a third-party solution called ThingsBot because to help speed up the development is one, and also because ThingsBot has a quite good in our experience, good features to enable this IoT type of application. Okay, all right. So how it works basically, our wireless sensor network runs on sub-gigahertz radio frequency, from 919 to 923 megahertz. So being at the lower end of the RF spectrum compared to 2.4 gigahertz, which what Bluetooth and Wi-Fi runs at. So at 900 megahertz, you can have a better radio propagation. So inside a factory or a building, the sensor can have a better reach or a better network coverage. So you do not have to have a lot of sensors to get your data to the network. In addition, each of our sensors also is mesh capable. So in the cases that the sensor does not, there is no direct path to the gateway. So each sensor can actually hop to the nearby sensor in order for the data packet to reach the gateway and onwards to the server. Okay, and each of our sensor also is running we call is running a IPv6 network stack. So meaning each of the sensor has its own IP address that you can reach from anywhere around the world actually. And our gateway basically is the root node, or maybe the top node of this mesh network. So the gateway basically perform two things. It becomes the master node of the wireless sensor network, and also it bridges the wireless sensor network to the Ethernet network. Okay. And another thing that the gateway does is that it also do the address translation. So because most of the cloud servers running nowadays are actually runs on IPv4 network, but our sensor are running on IPv6 IPv6 addressing. So in order to bridge between these two addressing mode, so the gateway does the network address translation so that our node can reach the remote server and vice versa. Okay. And finally, the backend server, this bot can either reside on the cloud that accessible by the internet, or it can also reside on a local network. The node communicate with the server using an MQTT protocol. So this is basically a subscribe and publish type of communication. The ThingsBot server is running a MQTT broker. So all the sensors actually publish the sensor data to this broker, and the broker will then reroute this information to each node that subscribe to this particular information. Right. Okay. So some of the advantage of our platform is that is quite a long range. We have tested in line of sight condition that it can reach about 5 kilometers. And also it runs on a license-free band. So it's a ISM band. In Malaysia, 919 and 923 is an ISM band. So we do not need a license for it. Due to the mesh capability of the platform, our nodes can expand a quite large area. It's also a self-healing network because the node can reroute its packet through good links to reach to the gateway, and also support two-way communication between the server and node. So you can upload data to the server, and also you can receive data or command from the server. Okay, so this is so the our this is our MySpark node. So MySpark node is actually the building block of our platform, IoT platform. So this node actually is based on Texas Instruments wireless chipset called CC1310. So on this particular PCB, we have also provisioned some sensors For example, temperature, humidity, gyroscope, accelerometer, light level, and pressure. So basically, if you, for example, need a pressure sensor, right? So we can just provision, or we can just populate a pressure sensor onto this particular PCB board, and that board becomes a pressure sensor because we have provisioned the pressure sensor on the PCB. We also provision a Bluetooth transceiver. So this is meant for integration with an external host, for example, a smartphone. On the board also we have our two type of antenna, either a PCB antenna or we can have an external antenna connected through a .UFL connector. And we also provision a 40 pin header so that we can extend the function of this MySpark board to perform to do extended function via a daughter board. So if we need additional function not covered by existing design, we can just create a new daughter card or daughter board, and then we just plug in this MySpark board on top of that daughter card via this 40 pin header. Okay. Right. As for the gateway, so if you can see the gateway, it's basically a combination of the MySpark board with a Linux host. So we use a Raspberry Pi board as the Linux host because it's a relatively small form factor and also cost effective. So our MySpark board runs the serial line IP firmware that basically transmit IP packet received by the radio into the serial port of the Linux host. While the Linux host then runs an open source software called 6LoWPAN border router. So this particular software is what actually bridge the IPv6 networks to IPv4 networks via network address translation. Okay. Okay, and finally the server, the backend server and the dashboard. Like I said, we use off the shelf solution called ThingsBot. The one that we use is the professional edition, but ThingsBot also have a community edition that is free to use, although it has slightly less features than the professional edition. But I think for most IoT application, even the community edition is sufficient. But if you need more features like reporting, platform integration, role-based access control, then only the professional edition has it. This server we hosted on premise at our Memos own cloud and accessible from this URL, myspark.memos.my. Right. Okay, so that is the a bit of introduction of our IoT platform. So from now onwards, I'll describe a bit or I'll explain a bit how we used that our IoT platform to perform or to do this smart chiller application. So okay, so in order to introduce IoT to HVAC system or a chiller, so you need to add a lot of sensors. So basically, you're gonna have things like temperature and humidity sensor to measure the indoor and outdoor temperature to get a view of the heat load. And then you also need power meter to measure the electrical consumption of the compressor, the water pumps, the fans, and all the electrical equipment. You also need to have this RTD. So RTD is also a type of temperature sensor, but it's meant for the process like this chill water. So you need an RTD to measure the return and the supply water. to know whether you are hitting the set temperature or not. And then you also need a flow meter. So there's two types of flow meter. One is for the air called CFM. So this will tell you whether you are getting enough supply of air and whether the ACSU or filter is blocked or not. And also UFM. Where is it? UFM is here. So UFM is the ultrasonic flow meter, basically to measure the flow rate of the chill water. So with this flow rate and also this USM also you can infer also the pressure. So you will know whether there is whether there are leaks in the pipes, or you can see whether the heat transfer of the chill water is efficient or not. So basically what you need is that you need a lot of these sensors retrofitted into the HVAC system. Okay. And this is what Square Cloud or the has done previously. So all their sensors that I have just described just now, all are wired sensors. So they have to install or wire each sensor to their control box and to their control panel basically. So you can see the line diagram is quite complicated, and they said they spend anytime between 2 to 3 months just to do the installation only. Okay. So we look at their requirement. So basically, like I said, we when we analyze the requirement from Square Cloud, we see that okay, they need a lot of um, temperature and humidity sensors. So in this diagram, these are the temperature and humidity. You can see one line here. There are a lot of them because they said in a large area, large building, you need a lot of these sensors to be placed to basically gauge the heat load or the basically the demand of the HVAC of the cooling. So they need a lot of these sensor to be placed around the building. Okay. So we find that okay for temperature and humidity sensor, this is a good this is a good uh, it's a good product to develop because if we have a wireless temperature and humidity sensor, that will allow the installation to be very easy. So they can just place it anywhere, and then they can just turn it on, and the sensor will wirelessly connect to the network. Okay, so that's what we did. That's what we did for the first product. So we developed this. It's a product called RHT. Basically stands for relative humidity and temperature. Like I said, it's a wireless sensor that measure ambient temperature and humidity. So if you remember earlier when I spoke about our MySpark board, right? So we say we have provision some sensors on board. So in order to just do this particular product, we just basically needs to populate a temperature sensor on it. So this is the location of that sensor. It's basically using an IC from Texas Instruments called HTC 1000. And the spec of that particular IC is here lah. So we can measure between 0 to 50 degrees C with plus minus 1 degree accuracy, and also humidity from 0 to 100% with a plus minus 3% accuracy. Okay, so this is how the product looks like. And another thing that we notice is that there are a lot of these sensor like the digital power meter, the RTDs, the RTD, the flow meter. So this kind of sensor are actually as a wired sensor that is already deployed in the factory, and all these sensors are running a specific a protocol, either a Modbus or a 4 to 20 milliamp interface. So we thought that okay, since this sensor is already being deployed in the factory floor, we decided to develop another product, what we call as WISP. WISP stands for Wireless Industrial Sensor Platform. So basically, this product is actually the layman function is actually to wireless to read the information from this wired sensor and to send those data wirelessly to the network. So basically, it's an interfacing. It is an interfacing device to these wired sensors or transducers, so that we can wirelessly then wirelessly send them to the network. So for this particular product, because our original MySpark board doesn't have any of these features or the Modbus and the 4 to 20 milliamp interface feature. So what we did was we developed another daughter board. This is the WISP daughter board that we can then plug in the MySpark board, because our MySpark board is the computing and the communication interface. So we need this to do the wireless communication. But what we have done is that we have developed the daughter board that has all these interfaces that allows this product then to be connected to the other sensors, industrial sensors and transducer. For example, the DPM, the RTD, the UFM, and the CFM. Okay. So with these two products that we have developed, so we can then now retrofit existing HVAC system so that we can collect data from the environment or from the process, and all this data wirelessly transmitted to the network via our gateway, and all this real-time sensor data is then processed at the server side. So Square Cloud and ICEE has their data analytics software that process all the real-time data that we have collected from all these sensors. So their data analytic engine then is able to then predict what is the operation or how the chiller needs to be operated as efficiently as possible. So then that information is then sent to the server via their chiller controller, so that they can regulate the operation of the chiller so that it meets the profile of the chiller, so that it operate in an efficient manner. So if you remember earlier from Mr. Selim presentation, right? There is the preemptive management of the chiller compared to the reactive, right? So this is where how Square Cloud was able to do the preemptive management of the HVAC, given the IoT data, real-time IoT data that we have gathered from our sensor platform. Okay, so after we have developed this, then this is after the installation. So this is what Mr. Selim showed earlier. So the installation now becomes more streamlined, more less complicated actually. So all the temperature and humidity sensors, the wired are replaced by the wireless sensor. So they just need to then just mount this to the required location, and the sensor will then find its and the sensor will then find the optimal mesh path to the gateway and onwards to the server. Similarly, for the DPM, because the WISP has the Modbus interface and all the DPM also has a Modbus interface, we can daisy chain the several DPMs together and connect it to one WISP. So the WISP will then wirelessly send the data from each of the DPM to the server. As for the RTD, so RTD uses I think 4 to 20 milliamp signal, and as well as the flow meter. So all connected to the WISP and then wirelessly transmitted to the cloud via the gateway. Okay, so the another advantage of being a wireless sensor is that it also allows the IoT installation to be scale up in the future. I mean, maybe for now they just install, for example, 50 sensors, right? 50 RHT. Then maybe they have a new requirement, so they want to install another 10 sensors. So being a wireless, because it's a wireless sensor, so it's easy for Square Cloud or for the SI to actually just install additional sensor, and then this additional sensor will then automatically form the mesh network to reach the gateway and then onwards to the server. Right. Okay, so we also have several improvement or several work ongoing currently, and also some future works. Right now we're also looking, because right now we have collected or the data, so we have installed the monitoring system. So what we are looking now with help of Square Cloud is that to actually analyze this data and implement some AI or machine learning algorithm to look at this data and try to figure out or try to predict how we can use this data in order to extract useful information that can help the factory or the building owner to actually further improve their processes. So one of the things that we're looking at is to see whether we can detect anomalies. We can detect anomalies in the HVAC equipment, or how we could use the information to do preventive maintenance and stuff like that. Okay, so this work actually there are two focus. One is looking at the machine learning or AI at the cloud. So because we have already collected some real-time data, so now we are processing this data in the cloud and try to extract useful information from it. But that data we only collect like I think every minute. So the granularity of that particular data is actually quite costly. So there are only certain things that we can do with a coarse grain data. In parallel, we are also looking at doing the AI and machine learning on the device itself. So what we call edge processing. So if we can run machine learning at the edge on the device itself, it opens up a more opportunity for us, because on the device we can do a much higher sampling of the data, up to like 4,000 sample per second, 8,000 sample per second. That this higher sampling data allows us to extract much more information from the equipment. So we are in parallel also working on edge type or edge based AI devices that can allow us to do this to learn the profile of the signal, to help us to actually extract usable or actionable information that we can then alert the user of what is going on. Okay. Another thing that we're looking at also is to implement over-the-air firmware updates. So currently, when working with Square Cloud, we noticed that certain time that we need to fix the firmware bugs, or we need to implement new features, we have to update the firmware on site. So it's quite a hassle. So one of the immediate things to do now is actually to do this firmware update over the air, so we can just if there are bugs to fix, or we want to implement new feature, that we can do it very easily. Another one that we are looking at also is to decouple our platform, the MySpark IoT platform, from ThinkSpot middleware, because we think by doing this, it provides a much bigger option for the user if they have their own preferred back-end software that they want to use, so they don't have to be tied to ThinkSpot, so that if they can just get our MySpark platform and then tie to their existing or their preferred software stack on the server. And finally, we're also looking at to modularize our MySpark radio because currently the platform perform two things basically. It's also a communication module as well as a computing module. So basically, you need to run your application on our board. So by modularizing this radio side, so we can treat the MySpark radio or MySpark board only like a wireless modem. So if user has their own application, right, or their own devices, and they just need to, let's say, use our wireless communication modem, then they can do this by plugging in this standalone modem, so that they can send their data to the internet using our MySpark IoT platform. So use cases for this is like, let's say currently they have their own application or their own device running cellular modem, for example. So cellular modem, of course, you need to pay monthly subscription for the frequency. So if they want to just, let's say, swap the cellular modem, they can do this with our MySpark modem. Just plug it in, and then our MySpark modem then talks to the gateway free of charge because it's a ISM, and only the gateway to the cloud or to the server may need cellular networking, or if you have a local internet network, and even better, so you don't have to pay for the cellular subscription. Right. Okay, so that basically ends the presentation. I have a couple more slides actually. So, but the next slide actually not related to the HVAC system, but nevertheless, I'm just trying to do a bit of marketing here. So we also see that our platform can be used for other things, not just for the HVAC management. One of the other use cases that we have done also with Square Cloud actually. So we have this program in the past called Smart Manufacturing. Smart Manufacturing Industrial Sensor Platform, or SMISP. This was a program under MITI last time. So they provide some grants for local SMEs to automate their processes. So we find that we can also use this product to do some level of automation in the factories. So what we have done, like we have installed it at Sankaya. So Sankaya is the ice cream maker. So we monitor their chiller and cold room. It's basically a temperature monitoring system, and then we send alert to their personnel or to their maintenance people when the temperature goes out of range. We also install this switch, read switch on the chiller door or cold room door to detect if the door is open or closed, and also to alert if the door is being left open for a certain amount of time. So that's what we did for Sankaya, and we also did some system for Strike Electronics. These are the PCBA assembler in Kulim, if not mistaken. So we also do some measurement or monitoring of some of the processes. Some other use case is this another project that we're working with Square Cloud. Earlier that our first project with them is to do efficient chiller management. For this project, we are doing compressed air controller, or basically to intelligently match the compressed air demand and with the compressed air supply. So this happens automatically at the process side. So this is another project that we're working with them to actually optimize the chiller, to optimize the air compressed air usage for the factory, to also help in energy efficiency. Right. Some other So we can also do maybe something like machine condition monitoring. So we can have a vibration sensor, like say for like a motor or a pumps, that we can send the data to our whiffs, and our whiffs can then do uh, on device digital signal processing to detect if there is a anomaly in the vibration profile. Then we can then alert the user through our gateway, and alert the user if we are seeing any anomaly detected on the motor, so that they can take the appropriate action. So this is another use case. Some other use case is for urban farming. So urban farming, so for WIS can be, because WIS has multiple interfaces that can be used to actually control, and also to actually get information from the sensors. So this is actually an example of how you can use WISP to do urban farming. For example, you have this pH, EC and pH sensor that you can monitor the solution, the A and B solution of the hydroponic soft system. And then you have some control that you can control the lighting and also the pumps to distribute the solution. And also, yeah, I mean, this is an example of what you can do with our platform. And lastly, I think this is the last slide. So you can also do water quality monitoring. So what you need is actually to have the sensor. So these are off-the-shelf sensors, water quality sensors. Then that connected to our WISP via 4 to 20 milliamp interface. And our device will just then read the sensor and then wirelessly send the data to the cloud or to the backend server. This is suitable for, like I said, our device can have a quite a relatively long range, about 5 kilometer line of sight. So if you put it on the outdoor, on the river banks or whatnot, and then you can use our wireless communication system to send the sensor data to the cloud. So you can have many sensor distributed along the river, and because we are using ISM band, so all of these sensors are not using, you don't have to pay for the network subscription. Only the gateway might need if you use the cellular networking to connect the gateway to the internet, then only you have to pay one license for one subscription for the network access. But all the other sensors will use the ISM band to transmit data from the sensor to the cloud. So basically, it's a lower cost, solution to do a large scale environmental monitoring. All right, I think that's my last slide. So thank you very much for your attention. And if you have any question, then maybe we can have some Q&A session. Over to you, Lawrence.
Thank you, Dr. Rosli, for that wonderful presentation. Looks like we have a question at the chat box. Could you please have a look at it?
All right, Alon, huh? So, okay. Okay. So one question here. So most commercial buildings and industrial have been equipped with BMS, BS, and BIMS.
The last one, Doctor.
Oh, the last one.
Yeah.
Which one?
From Mr. Clarence.
Okay.
1039. Yeah.
Okay. Can you please share more about the connectivity between the gateway and sensors in environments where there are thick walls or natural obstacles between? Okay, so all right. So like I said, because our platform uses a sub-gigahertz frequency, so sub-gigahertz means you have a longer radio wavelength. Compared to the Wi-Fi running at 2.4 gigahertz or even 5 gigahertz. So at 2.4 and 5 gigahertz, the wavelength is much smaller. So because of that, it's harder for the radio wave to go around obstacle, or what we call it a diffraction scattering phenomena. So with a longer wavelength, like 900, you can actually go around obstacle much easier compared to 2.4 gigahertz. Of course, if you have much lower frequency, that is even better. For example, like our AC signal, current signal like running on 50 hertz, right? So that's why they can travel very long distance because of the longer wavelength. But of course, the downside of sub gigahertz or lower radio frequency is that you cannot carry as much data or as much bandwidth as, for example, 2.4 gigahertz. So that's why there is a you need to weigh your option. But for IoT type application, that is fine because normally data packet send is actually quite small compared to Wi-Fi that is designed for more like a multimedia type of application that you send videos or pictures, right? So you need higher bandwidth for those type of application. But for IoT, you are okay with a few maybe a few kilohertz of bandwidth and also a few kilobyte per second. You don't need quite high speed because you don't need to carry a lot of bandwidth. Okay, is there that's I think I hope I answer you, Dr. Clarence.
Okay, any other questions
right.
from anyone?
I think they can just on their microphone, right? If they want to ask, probably it might be
They can
easier.
type, doctor.
Oh, they can type, okay.
Yeah. You can
Let
raise
me
your hands
see.
if anyone wants to ask any questions. Okay, doctor, can you switch on your mic? Sorry, your camera,
Okay.
and Mr. Salim as well.
What do we need to do now?
Okay, this time we have to hold on. There's a question here. Okay, I have a question for both of you gentlemen then. How much time does Malaysian organizations have to follow the ESG standards in US and Europe? Would you be able to take that question, Mr. Salim?
Yeah, okay. Basically, I think currently all this timing is all voluntary. However, I think the time will come when it's going to be mandatory. As stated, it will be about 2025, but we presume it will probably be in 2026. So we probably have about 2 to 3 years. But getting ready in all this will take time. It's a huge transition. It is not like just going over and you implement it. That's why even in SEDA grant, they look at the 3 years program, how you're going to be doing the audit and slowly going in and doing the improvement, right? So improvement process and transitioning will take about 2 to 3 years. So we should start now. We shouldn't wait until the time then we start and say, okay, we will not be ready because the MNCs and the customers are going to start requesting and say, what are you doing now? And what do you have now? And what are your plans to transition into net zero? Okay.
Okay, thank you, Mr. Salim. Okay, one last question for Mr. Dr. Rosli. So if organizations are interested to work with MIMOS, how should they start? What should they do first, Dr. Rosli?
Okay, so in MIMOS, we welcome external collaboration and also external parties to work with us and to collaborate on research and development. For example, if any party are interested to work with us, we have in our organization, we have a team that manage industry or academic collaboration initiative. So I mean, if anybody is interested, I think maybe we can. They send me an email. I think maybe later Lawrence will give me my email address. Just send me an email, and then I'll see that I can arrange on our side with the industrial engagement team, and then we can have the first discussion. So what are the scope of collaboration, or what are scope of engagement, and from then we can plan or fine tune the scope of work and what are the expected deliverables and also type of engagement. So it's uh, I would say our engagement model is quite flexible. So there is no really one type of engagement model. So they are variable. There are various engagement model that suits the external party. So this is all open for discussion. So in general, I think it just give us a email, and then we can touch base and further explore what are the potential work and the potential collaboration that we can move we can take on. Hope
Yeah.
answer that question.
Thank you, Dr. Rossley. And then I think one of the good things is that MIMOS also does training on the product, giving the people that work with them the training capabilities, getting them ready, in terms of how to implement whatever technology. So I think it is good. Register with Dr. Rossley, and then after that, the training will come along, and then see how it can be implemented, and they will be able to follow through with you. Is that okay?
Okay. So if there's no more questions, then thank you, ladies and gentlemen, for your attention. And don't forget to log on into mingusciencenegara.mosti.gov for more science activities brought to you by Ministry of Science, Technology and Innovation. With that, I'd like to thank Mr. Selim and Dr. Rosli for your wonderful contribution today. And thank you, ladies and gentlemen, for being a part of this wonderful webinar. Take care and have a productive day ahead.
Thank you, everyone.
Bye-bye.
Bye-bye.
Thank you, everyone. Yeah, bye.